Hi everyone. Today we're going to be talking about parallel and perpendicular lines. So this is lesson 2-6 for Algebra 1. Our goal today is to be able to write an equation of a line that is parallel or perpendicular to some other line. So we need to understand what it means to be parallel and perpendicular and how does that help us find the equation of a line. So our essential questions are: how do you tell if two lines are parallel or perpendicular or neither? And then how do you write an equation of a line that is either parallel or perpendicular to another line? So let's take a look at some lines here. So if I graphed this line, y equals 3x plus 4, it would cross through 4, right, and have a positive slope. So it would cross through 4 on the y-axis, our y-intercept, and it would go up 3, 1, 2, 3, and over 1. So it would have a slope of rise of 3 and a run of 1. If we graph this line here, 3x plus 6, okay, so it would start at 6, and it would also go up 3 and over 1. Notice that these lines have the same slope, right? They both have a slope of 3. So they have the same slope, but they sit at different, they cross the y-axis at different points. So one crosses at positive 4, one crosses at positive 6, but since they have the same slope, these lines will never ever cross. Okay, they can just keep going on forever and ever, just like a set of railroad tracks. They just go parallel to each other and they will never ever cross. So this is an example of some parallel lines. Let's look at this equation right here, this last one. So this is y equals negative 1/3 x plus 2. So it's going to cross the y-axis at 2, but this one has a negative slope, and it's a slope of negative 1 over 3. So it's going to go down 1 and 3 to the right. So it's going down from left to right. So look at this green line here as opposed to the red line and the blue line. It looks like it makes a 90-degree angle there. Okay, and then we call that a perpendicular line. So perpendicular lines just form 90-degree angles with one another. The x-axis and the y-axis are an example of that. But these are at different angles, but they make a 90-degree angle in between them. Okay, so we call those perpendicular lines. Now, we know that the red line and the blue line here have a slope of 3, right? But this one has a slope of negative 1/3. And so we try to understand the relationship between these. What we actually see is that what we've taken is this 3, right, turned it into a fraction, flipped it over, and then changed the sign. So this one becomes negative 1/3, right? We flip this 3 over, we turn it into a 1/3, and then take the opposite of it. So that act of doing that, right, flipping it over and taking the opposite, that's what creates, or how you can tell if lines are perpendicular. Okay, and we have some special terminology for that. All right. So this is what we're talking about: parallel and perpendicular lines. So parallel lines never cross, and then perpendicular lines make a 90-degree angle with each other. So here's our definition of a parallel line. Parallel lines are two lines that have the same slope. Okay, if we look back at this example here, the first line, the red line and the blue line, right? The red line and the blue line have the same slope. They have a slope of 3. So that's the definition of parallel. They have the same slope. Perpendicular lines are a little trickier. Perpendicular lines have slopes that are negative reciprocals. Negative reciprocals. Okay, so we've got some terminology here. First of all, we have this symbol right here, this double slashes here. We use that as a symbol for parallel. Okay, so we write that two lines are parallel. We'll just put that like that. It looks kind of like 11, but it actually means parallel. When you type it out, the lines are a little bit longer. It's easier to tell, but that's what we're talking about there. We're talking about parallel, and then for perpendicular. For perpendicular, we use this upside down T, and you see those lines make a 90-degree angle. So that's why we use that symbol. So it's just this upside down T. That means perpendicular. Okay. Negative just means the opposite sign. Okay. But this word reciprocal here, right? Reciprocal, if I have a fraction of 3/4, the reciprocal would be, just flip that over. Reciprocal. That just means to flip it over, right? It's the inverse of that. So the reciprocal would be 4 over 3. Okay, so that's what reciprocal means. If I have just a number, if I have the number, say, 2, and I wanted to find the reciprocal of that, well, I'd turn it into a fraction, and I'd flip it over. So 2 was my original number, 1/2 would be my reciprocal. And likewise, if I had a fraction, right, if I had 1/4, right, and I wanted to know the reciprocal of that, well, I'd flip that over. That would be 4 over 1, and so we just write that as 4. Right? So all these numbers here are all reciprocals of each other. But in order to be perpendicular, they can't just be the reciprocal, they have to be the negative reciprocal. So the sign of that number has to be the opposite. So if I had a slope of 3/4, and I had another line that had a slope of negative 4/3, I would know that those two lines are perpendicular to one another. So here's an example of something you might see. They're giving me a line. So they tell me this line right here, y equals negative 2x plus 4. I want to write an equation for a line that's parallel to that, that goes through this point. Okay, so parallel to this line. That doesn't mean I want this line. I want a line that has the same slope. That's what the parallel means. I want a line that has the same slope as this line. Well, what's the slope of this line? The slope of this line, I can tell, because it's in slope-intercept form, I can tell that slope is negative 2. So what they're really asking me for is they're saying, write an equation for a line that has a slope of negative 2 and goes through the point negative 1,3. That's what they're really asking. Okay? They're providing me the slope, but they're doing it in this kind of roundabout way. They're saying it's parallel to this line, so you have to know that parallel means same slope. This has a slope of negative 2, so my new line is going to have a slope of negative 2. Now, once I get this slope off of here, right? Once I get the slope off of here, I know that my parallel line, right? My parallel line is also going to have a slope of negative 2. Okay. Now, I'm done with this. I don't need this line anymore. I don't need that slope anymore. I don't need any of that. I know that I have my parallel slope, and I know that I have a point that it's going through. So it's going to go through this point, negative 1,3. And it's going to have a slope of negative 2. So how can I write that equation? Well, they don't specifically say what format it should be in. So I can choose which one that's convenient for me. If I chose one that was be convenient, well, I have a point, I have the slope. I'm going to use point slope because that's just an easy way to do it. So point slope, remember, is y minus y1 is equal to the slope times the quantity x minus x1. And x1 and y1 are just simply the point that values the x and y portions of that coordinate that I have. So if I wrote this out, I'd have y minus y1, which would be 3, y minus 3 is equal to my slope, negative 2, times x minus, now I gotta be careful here, because my x value is negative 1, so it's minus negative 1. So that gets a lot of people. So I have y minus 3 is equal to negative 2 times x plus 1. Okay, so again, they didn't specify what format that equation should be in, so I chose this form. If I chose, slope-intercept form, I could take this equation and, distribute and move things around and get the y all by itself and get that in slope-intercept form. If I wanted to put it in standard form, I could do the same thing. I could distribute this and then move the terms around and get the x's and y's on the same side, get the constant value on the other side, make sure that I have only integers here. So I could do that. We've done that in other problems. Okay, but here, just this provides me a nice kind of quick way of getting a start on that line. Right? Here's an equation of a line, and I can then play with it and put it in whatever format I want. Okay, so here they give me a number of lines here, right? And there's an issue with this one right here. That fraction got dropped somehow. So here's a number of lines, right? And what they're asking me to do is they're asking me to write the slope of a line that's perpendicular to it. So if I look at this right here, right, this has a slope of 2. So my perpendicular slope, right, my perpendicular slope is going to be the negative reciprocal. This number is positive, so I'm going to have negative, and the reciprocal of 2 is 1/2. So there's the slope of a line that's perpendicular to this one. Likewise, this second one here, this one has a slope of -4. So a slope that's perpendicular to that is going to have the opposite of -4, right? The opposite of the negative, so that's going to be positive, and then the reciprocal of 4, which is going to be 1/4. So this one's going to have a slope of positive 1/4. This has a slope of -4, so we take the opposite and flip it over, so it's going to be positive 1/4. This line has a slope of -2/3. It's hard to see, there's a negative in front of that, so -2/3. So my perpendicular slope is going to be the opposite sign, so it's positive, and it's going to flip that over. So it's going to be 3/2. Now, this one, right, the slope of a line that's perpendicular to this, well, there's some issues with this line, right? This line should stand out to us in that it's not in slope-intercept form, and in fact there's no x in it. Okay, so this should pop out to us, and we should say, well, look, there's no x values in this. It doesn't matter what my x value is. My y value is always going to be 5. If I were to graph this line, right, if this is y equals 5, right, my line is going to go right through that. My line is going to be a straight line that's going to go through that. All the y values are going to be 5. So if I was looking for a line that was perpendicular to it, right, a line that was perpendicular to it, a line that's perpendicular to it is going to be a vertical line. This is a horizontal line. A line perpendicular to it is going to be vertical. And so a vertical line has a slope of undefined. So my perpendicular slope here is going to be undefined. Right? It doesn't exist. Okay, and that's an important concept to understand, right? This has a slope of 0, right? As y equals 0x plus 5. And the reciprocal of 0 is 1/0, which is undefined. So we have a slope of undefined here for this, for a line perpendicular to this one. And likewise, this line right here, x equals -2, well, that line's going to, look something like this, right? It's going to look like this, where this would be -2. Okay, that's x equals -2. So a line that's perpendicular to that is going to be a horizontal line. And I know that all horizontal lines have a slope of 0. Okay, so we have these special cases. One thing we want to do is when these special cases pop up, we want to make sure that we understand what that means. When we just have y equals 5, that's a horizontal line, right, through the value y equals 5. And then when we have x equals -2, that's a vertical line through the value x equals -2. So where x is -2, that's where that line's going to go. And then our last example here, they're asking us to write an equation of a line perpendicular. So perpendicular, right, to this line through this point. So perpendicular. So this line, my slope is -3. Okay, I know that slope is -3. For my new line, it's going to be perpendicular to that. So my perpendicular slope is going to be positive. Sorry, going to be positive 1/3. Okay, so my new line that I write the equation for, this new line is going to have a slope of 1/3. It's going to be perpendicular to -3. Okay, so I don't need this anymore. I don't need this anymore. All I'm being asked to do is write an equation for a line that has a slope of 1/3 and that goes through this point. So again, they don't ask me, or they don't tell me to provide it in any specific format. So I have a point, I have the slope, I'm going to use point slope. So I'm going to go y minus my y value, which is 3, is equal to m. So my line perpendicular is going to have a slope of 1/3. and then x minus my x value here. And again, this is going to be negative, negative 2, right? It's going to be negative, negative 2. So minus negative 2. So I'm going to get y minus 3 is equal to 1/3 x plus 2. Okay, and if I just needed an equation, I could leave it like that. If I wanted to turn it into slope-intercept, I could do that. I could simply continue on here. Distribute this. This is 1/3 x plus 2/3. To get the y by itself, I would add 3 to both sides. So if I come up here, I would have y is equal to 1/3 x. And then I would have to add together 2/3 and 3. Well, to do that, I'd have to have a common denominator. So 2/3, and if I wrote 3 as thirds, that would be 9/3. Right? 9/3 is the same as 3. And so I would add those together, I would get 11/3. So there's another equation that works. So we have point slope, and we have slope intercept. And if we wanted to go ahead and move that into standard form, we could do that as well. We could multiply everything by 3, and then we could move stuff around. So that's really our goal today, right? Is first understand what parallel and perpendicular mean, right? What do those words mean, and mathematically, what do they imply, right? And then the second part is to be able to find lines and find slopes that are parallel or perpendicular to other lines. So your assignment today is, I believe, only 7 questions, so take a look at those, and if you have any questions, please let me know.